Hello PLP Geometry, welcome to Unit 6 on circles, and we are covering lesson number 5 today, and today's big topic is an idea of chords. Okay, so we'll talk about chords. We'll do one theorem, one problem, and that'll be a short video today. Okay, so this is lesson number 5. Sorry, got so ahead of myself. I'm going to put chords. Lesson number 5 on chords. Okay, so what is a chord? So a chord is a segment whose endpoints are on the circle. Now we know a special type of chord called the diameter. So the diameter, so special note, the diameter is a special chord passing through the center of the circle. There you go. So again, keep that in mind. As we talk about diameters going all the way across the circle, it is really just a special chord going through the center. Okay, the other word we're going to talk about here is secant. Now again, we're not going to focus on secant, but I do want to teach you this word. So a secant can be a line, ray, or segment. That I'm going to leave some space over here for a picture. So I'm going to come over here. That intersects a circle at 2 points. And I'm going to put in parentheses, it's just a chord extended. All right, so let's come over here and let's draw a picture of a circle. So I'll use green to draw this picture. So here is circle C. Okay, so let me draw my first segment, and let's draw a chord, right? So if I start here at R, and I just draw it to S, there we go. So that is a chord. So we have a chord, and that would be segment RS. Okay. Now let me change colors to purple. Now let me draw a diameter. So a diameter could involve S going through point C to the other side of the circle, call that point T. So a diameter here, let me move this toolbar up here, and always doesn't like to be messed with. So a diameter here would be ST. Okay? And then lastly, I'll do it in red. If I start here at, or not start here, T, if I go through T, through the circle again, and let's call that point U. So then a secant in this picture, a secant would be a line to U. Again, I could also extend RS, and that would be a secant too. Same thing with ST, right? So any chord extended could be a secant. Okay, so again, secant was a bonus thing for you. Congratulations. But we're really focused on the diameter and the chord, and that is the title of our theorem. So the next theorem we're going to talk about is the diameter chord theorem. Okay, so the diameter chord theorem. So the diameter chord theorem says if a diameter if a diameter is perpendicular, to a chord, then it bisects. The chord. Okay, so let's draw a picture of a circle. Let's call this circle P. Okay, so I'm going to draw a diameter. Oh, actually, let me draw a chord. So let's draw chord AB first. So there's chord AB. So if I have a diameter or a part of the diameter, because it could be the radius, right? If I have a diameter being perpendicular to this chord, so again, if I start here at P and I go, I'll use dotted, and I make a right angle, and again, you can extend it. It can be however long part of this diameter is, but it has to go through the chord. So let's call this C and D, right? So if I know that that is a right angle right there, then I know that A and B, that segment, is split into two parts. So if I put like a point E right here, I know that A to E, let me use a different color. Let me use like green. I know that A to E is congruent to B to E. Okay. So again, in math symbols, so if I know that segment CD, that diameter, is perpendicular to AB, the chord, right? So we have the diameter here, diameter, that's the chord. If they are perpendicular, then I know that segment AE is congruent to segment BE, right? It's being bisected. Now, if we take this picture, and if I draw a radius in a clever way, so I'm going to draw this radius so it goes from the center P, where it has to, out to A, or I could draw it to B, but I'm going to draw it out to A. Let's call this the radius. Now, I hope you can see that we've created another right triangle. AEP, this triangle, is a right triangle. And again, when you have a right triangle, we can use Pythagorean theorem, just like we did in the last lesson. Pythagorean theorem, A squared plus B squared. I always put plus. A squared plus B squared equals C squared. So be aware. Okay, so let's in fact do a problem where they give us a diameter and a chord being perpendicular, and let's find the radius. Okay, so our only example here, find the radius of the circle. Find the radius of the circle. Okay, so we have a circle here. Let's call this circle P. We have a chord here. Let's call this chord QS. And we have this part of the diameter. We're just going to do the short part from P perpendicularly down. Call that R. So it creates this right angle. Okay. Now, in this problem, it gives us that PR is 1.9 and QS is 9. And the question is, what is going to be the radius? So a couple things, right? So first off, if the radius is not drawn in, we need to cleverly draw the radius in. So that radius would be right here or on the other side. There's my radius. Now it says PR is 1.9, so I'll put the 1.9 right there. Now it says QS is 9, so this entire thing is 9. Well, if we use this diameter chord theorem, because the diameter makes a right angle with the chord, it's going to bisect this chord. So to find QR, which is also SR, we're going to take half of 9. And half of 9 is 4.5. This length is 4.5. 4.5. And now we can use our friend Pythagorean theorem. A squared plus b squared equals c squared. Now in this picture, the hypotenuse points to the c, that is our radius. A and b do not matter. I'll let the 1.9 be the a and the 4.5 be the b. So our formula now says 1.9 squared plus 4.5 squared equals, and let's call this r squared, the radius squared. I will type this in all at once, and when you type it in all at once, you get 23.86 equals r squared, and then to get rid of the squared, we will take the square root of both sides. And when you take the square root of both sides, you get 4.88 equals r. They want us to round to the nearest tenth. This 8 rounds that 8 up to a 9, so our radius is 4.9, and that would be units. And there we go. So again, just some fun ways to apply the Pythagorean theorem into some circles. Okay, thanks for watching, and we'll see you in class.